I don't have any cats or animals. My puddings have animals.
What?
Actually, no, I have.
Guys, we are one day ahead in notes. So tomorrow I'm gonna be checking 9.5 and 9.5B classwork problems as well as AP practice, but we've already gone through all the notes for this. So today I wanted to motion along a curve. And then that way I can have 2 days, tomorrow and Friday, just to kind of take our time through the graphing polar equations as a prep before we get into the area next week. Okay, so we'll start with 9.6 notes today. So page 27. Okay, so position, velocity, acceleration, just like what we would expect. If my vector is r of t, then and if it's split up into x and y components, then the velocity is simply r prime, which is just taking the derivative of the horizontal and vertical components. And acceleration is just taking the second derivative for the horizontal and vertical component. Speed is the magnitude of a velocity vector. So speed has no direction. It's just this magnitude. So it's denoted by this double bar v of t or double bar r prime of t, and it looks like this. So it has that distance feel to it, square root of x prime of t squared plus y prime of t squared. Okay, so let's look at example 1 here. Find the velocity vector, speed, acceleration vector for the particle that moves in the xy plane described by r of t. Yeah, so let's find the velocity acceleration first. So really we're just going down the line and taking the derivative of each component. So sine of u becomes cosine of u times u prime. So sine of t over 5 becomes what? Cosine of t over 5 times, what's the derivative of t over 5? Yeah, 1/5, yeah. Okay, I can do some cleanup there. And find your acceleration. Acceleration is the derivative of your velocity in horizontal and vertical component.
And speed is just the square root of my velocity components added together. And Pythagorean identity allows us to reduce that down to 1. The square root of 1 is just 1. Okay, a little bit of review from last semester. When does the particle speed increase or decrease? So if the particle is speeding up, velocity and acceleration have to have what? Same signs, yeah. If it's slowing down, velocity acceleration needs to have opposite signs, different signs, yeah.
If it's increasing velocity, I just check acceleration.
That's right. Increasing velocity is just acceleration, but increasing speed, decreasing speed is velocity and acceleration. Good. All right, so number 2, if R of t is given by my vector value function there, find velocity acceleration. So go down the line of finding the derivatives, keep them in component form. Okay, any questions with 2? Number 3 says, find the speed at time t equals 2 if r of t equals 3t e to the negative t squared. So what we can do is we can find the velocity in component form. Then we can plug 2 into the velocity vector. And then we can figure out x prime of t squared plus y prime of t squared and see if we can get it down to a number. And that will be our speed. So find your velocity vector, plug 2 in to get your velocity value in component form, and then put it into this formula. Okay, so v of t is just the derivative. 3t becomes 3. E to the u becomes e to the u times u prime. We can find v of 2. And we can take our x prime and y prime, insert it into our square root formula, and get our speed. Yeah, any questions? 3. Okay, so we know speed is related to velocity, right? So if we take the antiderivative of speed, that will get us into something that is in that position range. So here, total distance kind of has that is the antiderivative or the integral, definite integral of velocity, absolute value of velocity. So basically, we take the speed component. We know speed is always going to be positive, right? So if we accumulate all the speed values, and if we accumulate all that, all the positive velocity over the course of an interval, we're going to get total distance. So we're just adapting, putting integral around speed to get to our total distance traveled along a curve or a function that is in component form. Okay, page 28. All right, so it's given the velocity vector v of t equals 2t plus 1 and 5, and the position of the particle is 1, 2. Find the position when t equals 3. So that's the first part, and then we'll do the total distance later. So recall we have that final position equals initial plus displacement, which is just really a rearranging of first theorem. So if I want to find my final position, I can just figure out my initial position plus however much I travel. I'm going to do this twice, once for the horizontal component and once for the vertical component, and then I can get to my position at 3. So I'll do x of 3 first. If I want to find x of 3, I know I can start at x of 0. I know x of 0 is 1, plus definite integral from 0 to 3 of my velocity of my horizontal component of my velocity function. Okay, so we do power rule here. X of 0 is 1. 9 plus 3 is 12. So my position at t equals 3 has a horizontal value of 13, horizontal component of 13. Now we can do y of 3. Part B, total distance. We'll use our distance formula. Integral from A to B, square root of x prime of t squared plus y prime of t squared. And that's too difficult for us to do by hand. We can use our calculator. If you enter this in your calculator, just still use the variable x, even though you put everything in terms of t. Use x as your variable. You can get that approximation. Okay, questions here? All right, number 5. A particle moves along a curve so that its velocity is given by v of t. We have 2e to the negative t over 4, which is going to give us information about the horizontal movement of this object, of this particle. And then we got the y component of the velocity, which is telling us when this object is moving up and down. So it says, for what values of t is the particle moving to the right? So moving to the right would mean where my horizontal component is what? Positive. So is this ever going to be negative? It's always positive, right? So we can say that this particle is always moving to the right. As long as our t value is greater than or equal to 0, we're never going to experience a horizontal velocity that is negative. Okay. The horizontal direction of our motion is determined by the x component of the velocity vector. And since 2e to the negative t over 4 is always greater than 0, right? Even if I have a e raised to a negative exponent, that's still a positive number. So particles always move to the right when t is greater than or equal to 0. Okay, but for part B, there are some restrictions, right? For what values of t is the particle moving up? So moving up, that means my fraction has to be, for my vertical component, this has to be what? Positive. So what t value or what range of t values can I guarantee that I'm always going to get a positive vertical velocity? We're in the 4, right? Now, yes, numerator and denominator, they both require to be positive, but we take the more restrictive and we just use that, right? Because denominator, all it needs is t greater than or equal to -5, which is less restrictive, but t is greater than 4 is more restrictive. So we just take the more restrictive one, and that will guarantee if t is greater than 4, my numerator is always positive, my denominator is always positive, and I guarantee a positive vertical component. Okay, so for the next 15 or 20 minutes, let's just see how much we can do with the practice problems. So we can kind of just get comfortable with 9.6. So when eventually, when you have to do this for homework, you'll be comfortable enough where you can work through the rest of the problems. But yeah, let's see if we can maybe get through to number 8. And I'll show the answers along the way, and I'll also walk around, see if you guys have any questions.
For number 2, one that connected the X. Oh, wait, never mind. You got.
The T cannot be negative at all.
T can be negative, but they will have to specify that in the restriction. If it says T greater than 0, then we have to leave it as, which problem are
The
you?
first one, there's no specification.
Oh,
Oh, you.
So here, for number 3, we figure out the T value where the particle is going to pass through that 0.44. And because there's an agreement between the X and Y component, we know that the velocity is only going to be at T equals 1.
Oh, they have to agree.
They have to agree, right? They have to agree so that, yeah, they will, right? They have to agree.
I just I don't know why problem dress. You need to use this set time. After the one for no, I thought it was large, so, you know, that's already. It makes sense. If you play that, we should just plug in these from 0. Well, watch. Oh, no, but that's not. Find the T by. The grade after. Because what you have to do is you have to say 3 is 9, actually, 3 is now equal to 0. And then it's like grading just. Oh, you got equals 9, negative 5. Yeah, plug in 5, that's 5 is not. 0. The plug in 5 does. And then why do you plug in 5? Like, I think I wasn't inside. No, T equals 0 and it's very easy. I do it. The idea of the lines. I know, but if everyone else did, like, the sign is 0, it's expected to be. Oh, yeah, that is wrong. Oh, it is. And that's fine. 5 is 0 here. Oh, so I guess here is 1. So what's going to be for the yeah, he's not this solution. He's not when you gotta go ask. Yeah, fine. Oh, yeah. Wait, but there's no negative 5 doesn't count because we're reading a primary value. But there's what you do. Try to wait. Or just ask or use. This feels like a way of getting it like 40 ones. Why do you do it? I think he did 0. He did, oh, yeah. It's so that's. You get 7. That's really.
hey.
The question for this, yeah. Well, it says find the slope of tangent lines at the point of the intersection, right? So this is the slope formula, right? What will you plug in for T? Because there's 3 T values, and I don't think the slope is 0.
Just figure out which.
This one.
So when they intersect, we have to figure out where X and Y have the same P value at 0. Let me look.
Is it last one? Yeah, give me a minute. I'll Sounds like it's on like yeah.
I mean, it's like.
I got one. Typically, if you get the right answer. Well, I mean,
They will have 35 pieces of election time. But do you see?
oh, I don't know if I got it, but I got an answer.
You're sure. I remember last time we had a good study. I say that we talked for a long time. What is nice stuff? But today.
It's like I missed up the layer. No.
So how you got in your house?
Huh?
Oh, yes. That's the whole thing.
So this is what I have in my calculator. Let's find the numbers P that correspond to the 0.05 squared. So if I plus 0 pi squared n. I'm looking for like we're not so 0 to pi n. Zero because 0. Because if I plug pi squared into or y, if I solve for t, I'm not getting 0 here. I'm getting 0 here, but I'm not getting 0 here.
Oh, but you get five
Here. So I'm looking at what is, you gotta match. Okay, you gotta match at the same time. So I know it's what it says find the slope.
So you just plug in
Find
five.
into dy over dt, and just find their slope.
Specifically, that's not. Gotta be a reference. They should be professional all year round.
Over last week.
Yeah, and like, that's like. Negative part of it.
Yeah, so they overuse them.
But the fuel is. But it's. Like right around the bell, I figured out. I just got it.
Hey, I.
Maybe not, but maybe.
No, so.
Find out why they think it's like a bird.
Yeah, the way he
All you get is.
it's like literally just writing some stuff out in the folder. You know, if you don't unlock it, and he's like, oh, it's like you're already you're following it. You know, when you're learning about like so
What would you do with it?
maybe not stop working with your legs.
Finally got the answer that I want. That's really.
I played a tennis ball. Yeah. Well, it makes it close. That's my dream.
I'm not in the process.
Suppliers, yeah, guys.
Like when I took the Northern American
That's so
honestly,
nice.
and I would rather call myself.
Gonna go.
At least it's so good, so easy, the best teachers since that. Like my teachers. So, I like June for sure. And don't even get me started.
Yes.
Because I know she was.
It's usually.
It's like 30 seconds.
I'm gonna do last like 5 minutes, I speed up that. But the video, the facial distortion, like it's like John Hart is really full.
The curiosity. Is so
Actually, this is.
Yeah. Yeah.
Trust me.
Classic.
Even though it's crazy, go like.
I mean, stuff.
It's like I'm offended because I haven't seen a thing like that.
South Park.
Yeah, you know, like.
Yes.
But it's two guys. So it would be.
Whoever looks like that.
Yeah. And it is.
Yeah.
So you're not seeing the left. Yeah, but.
Whoever runs. It's
Yeah, it's.
like the interesting part.
The only country wins for 50 home. This is the game.
It's a new.
No, but you didn't call it. But also you said it.
Some words of one time. I'm sure it's just the BBC. Find it.
Yeah, yeah, it goes travel.
All right, guys, your homework tonight is everything from 9.5, so page 20 to 26. And then tomorrow, make sure you bring your calculators. We're going to slow down and really spend time with polar equations. We'll split Friday's lesson into 2 days, Thursday and Friday. We'll take our time with it. Okay. All right, mute your phones.
The library.
No, I'm. So I did not.
Honestly, we're going with as low level. What would have done for this guy?
It's probably. But I also have some, how big is it?
Yeah. What do It's like. Actually, yes. And I draw my return fees on there. Sorry. Wait.
Wait, like that.
Yeah, you get a, I got to get black on the face. Oh, yeah. Just eat them, it's like, no, it's, yeah. I'm just said, oh, this, like, kill your stuff, like, so he's just like, like,
It doesn't say so. It's like, no,
probably like, I still don't want to, yeah.
well, like, it does not.
I'm sick.
Oh, and then make sure you have access to the solutions.
Yeah, I just.
Yeah. Well, it's not care, but.
All right, great. All right, thank you. Thank you.
I mean, I that we
My goal in life is to be rich enough to afford like 4 Nespresso machines and then have my own coffee shop. And I get that.
Yeah, there's something. You know, I was like,
Change it, Boston, take a shopping stores.
Videos I do. I've been talking about.
Like it has.
I know Jason said he's like 37. Yeah, he said I was like 37.
Bad.
I know. I wonder if I'll go take this.
Yes, anybody. And so, yeah. Yeah, and like,
And it's not good, they just don't get it. It's for them.
Anyways.